Okay, this is 2.5 to 2.8. 16 questions. Which of the following is true about instantaneous velocity? It's a vector quantity, okay, because it's still velocity. The magnitude of instantaneous velocity is equal to instantaneous speed, okay, because instantaneous velocity is basically the velocity at a certain instant, so it's equal to the instantaneous speed. Since it's the magnitude. Magnitude, يعني the positive value of the instantaneous velocity is equal to the instantaneous speed. I mean, I don't think I have to explain that. Okay, instantaneous velocity is represented on diagrams. Okay, blah blah. These questions, Damon, they come. Okay, is speed velocity in a direction? Of course not. Does it have zero instantaneous velocity if it's moving? Of course not. Question 2. The motion in which an object has a constant speed in one direction is referred to as URM. Constant speed. مش constant acceleration, constant speed. URM. The motion in which the velocity of an object increases by equal amounts in equal time intervals is equal to as uniformly accelerated. When the velocity is increasing, that means it's accelerating. Okay, so it's uniformly accelerated. Question 4. Okay, I froze. Okay, there you go. So they have us x and t, the average velocity between 0 seconds and 7 seconds. To find velocity average, okay, it's x final minus x initial over time final minus time initial. So in this case, it's going to be the final x at 7 seconds. Where is 7 seconds? It's 32. Okay, so 32 minus, okay, 0 seconds, it's at 0. So you can just say, divided by time final minus time initial. Time final 7, and akid initial time is 0. So 32 divided by 7, and that's gonna be 4.6. Wait, is it? Why did is 32 divided by 7 4.6? No, it's not. No way, is it? 32 divided by 7. No, wait, 7. To the nearest, okay, yeah, to the nearest decimal point, it's 4.6. Okay, question 5. Uh, the average velocity between 0 seconds 5 seconds. Okay, between 0 seconds, wait, between 0 seconds 5 seconds. Oh, 0 is up here, sorry. At 0 seconds, it's at 10, and at 5 seconds, it's at 5. So we're going to do average velocity is final minus initial over final minus initial, right? So it's going to be final displacement, which is at 5 seconds, it's at 0, subtracted by the initial, which is 10, okay, divided by the time final minus time initial. It took me 5 seconds, صح? For 5. Okay, you're going to get minus 10 over 5, which is minus 2. Top, what is the average speed in that interval? Okay, you can calculate it. You can look at the distance followed, okay? From 10 to minus 20, that's 30. Then from, wait. Then from 30, hello. Yeah, sorry, it's correct, yeah. So for speed, you have to find the total distance traveled, right? Speed is distance divided by time. Okay, فبنبلش, you have to look at the total path. Okay, this is x. But choose an the distance, you look at the total path. You go from 10 to minus 20, that's 30. Then from minus 20 back to 0, that's 20. So 30 plus 20 is 50 as my distance. Okay, well, time from 0 seconds 5 seconds, أكيد 5 seconds. Let's see, 10 meters per second. Okay, بعدين I think بيسألوا instantaneous speed. لا ما بيسألوا. That's a different question. Okay, question 6. Okay, what is the speed? Look, people see this question and they get confused, and I'm not بعرف why, but it comes in the AMS. Yeah, I mean, all you have to do is just subtract final velocity, sorry, final minus initial, final minus initial. I don't understand why people, they still get it wrong. Okay, you can do 0 minus 5 على 4 minus 10. Okay, يعني speed. Okay, it's going to become negative 5 على negative 6, which is 5 over 6, which is 0.83. Okay, speed, distance divided by time. بس يعني when you're working with 2 points, you need to subtract them. So distance over time, you could just say distance final divided by distance initial. Oh wait, I just realized when I gave you the equation for average velocity in the 2.1 to 2.4, I gave you x over t, but it's actually delta x over t. Sorry, huh? Question 7. The quantity that describes how fast at a given instant, again, is going to be called instantaneous. Okay, at a given instant, it's instantaneous. Question 8. I'm going through these a bit fast. Yeah? The initial velocity is 20, decreases to 2 in 3 seconds. Okay, what is the acceleration? Okay, average acceleration is the change in velocity over time. You know, velocity over time. So how would I find average acceleration? It would be delta v over t, right? Delta v over t. Delta v is the change in velocity. So final velocity, vf minus v initial, على time final minus time initial. Okay, velocity final is 2 صح؟ initial is 20 ف minus 20 على time final minus time initial. Okay, الفاينل time minus time initial is going to be 3 seconds. They give it to you يعني in 3 seconds يعني that's your time. ف you're going to get minus 18 over 3 which is going to be minus 6. Don't forget unit per second squared. Okay, minus 6.0 per meter per second squared. Question 9. What is the average velocity between 0 seconds 3 seconds? We're pretty much repeating ourselves. From 0 seconds to 3 seconds is up here. Okay, what is the displacement? Okay, from 0 to 2, you could actually say x final minus x initial على time. Okay, our final is at 2, right? Minus initial, which is 0, divided by the time, which is 3. You're going to get 2 over 3, which is 0.67. Okay, meters per second. Question 10. Okay, they give you time and speed. Okay, the average acceleration during the 3 seconds. Okay, how do you find average acceleration? Again, delta v divided by t. فيعني final velocity v final minus v initial على time. Okay, the final velocity here at time 3 it's 1.8. Okay, minus initial velocity which is أكيد 0. Okay, divided by the time taken احنا we're taking 3 seconds. Right, ف 1.8 divided by 3 is 0.6. Okay, it's gonna be 0.6. They said to one decimal place. I don't know why they put it like that. Okay. What can be said about the acceleration of the steel ball is constant. How do you know it's constant? You have to divide this by this, this by this, this by this. Okay, check if they're the same. Uh, since it's constant, that means it's UARM. That's for 2.10, 2.14. Let's stay on what we're doing right now. Select the XT graph that describes the following motion. A car stays at rest for some time. Okay, then begins moving at a constant speed v towards the origin. Okay, so it stays at rest, right? xt xt is the distance. So if it's staying at rest, yani the distance is not changing, right? So it's staying constant. Okay, it then begins moving at a constant speed v towards origin. Constant speed v يعني it's شو اسمه straight line. Constant يعني straight line, not curved. Okay, towards the origin. Once at the origin, it turns around and moves away from the origin at a constant speed u. So it decreases until it reaches the origin. Let's call this the origin here. Okay, it reaches the origin. Okay, once at the origin, it turns around, so it turns back up and moves at a constant speed. So again, straight lines, it's a constant speed. So obviously, it's going to be this one. Okay, origin is the 0. طب some people might argue, what if it starts like this and like this? If they gave this, that would be correct, because technically here it's constant. Okay, it went to the origin, it turned around, it moved back at a constant speed. So technically that would be correct, but here it's not part of the options. Okay, basically they want to they want you to give the correct time interval at which it describes the motion. Okay, it moves away from the origin with a constant speed. Okay, so we want to be at the origin. Where do I have, where am I at the origin on this graph? I have 2 points here and here. But they're saying moving with a constant speed, so actually it won't be the curved one, it's going to be the straight one. So it's going to be this one from 2 seconds to 3 seconds. Moving towards the origin with a constant speed, okay? Moving towards the origin, not away from the origin. Where is it moving towards the origin? It's moving towards the origin at a constant speed. So where is it a straight line going towards the origin? It's here, right? So from 1 second, from 0 second to 2 seconds. Moving towards the origin with a varying speed. Varying, yani it's curved, okay? Towards the origin. Where am I going towards the origin? Here. Where is it curving towards the origin? Here. Moving away with a varying speed. Now, again, at the origin, where am I moving with the varying speed? So where is it curving away after the origin? Here, from 5 to 6. The previous one was 4 to 5. I didn't see it for some reason. Then I think there's more at the bottom. At rest, أكيد at rest would be when it's not moving, صح? So if it's not moving, يعني the displacement is constant. So there's no movement, right? It stayed negative 10. It stayed at the position of negative 10 since it's not moving, it's at rest. Question 13. What is instantaneous velocity at t equal 2 seconds? Okay, t equal 2 seconds over here, yeah? How do you find the instantaneous velocity? Okay, you will get a question like this, I'm sure. Okay, if you want to find the velocity from a graph and you don't have any numbers to do at that point that they ask from you, okay, you most probably, more than likely, 99% of the time, that point would lie on a straight line. Okay, it would lie on a straight line. And since it's on a straight line, what did we always say about straight lines? That they have a constant speed throughout the whole line. فمعناتها if I find the speed between 1 second and 3 seconds, it's going to be the same speed as 2 seconds. Okay, for uh, let's find the speed of this line. It's the same thing as just finding the slope. So I have at 1 second, my x is 0, so 1 second, 0 meters, and at 3 seconds, it's negative 20 meters. So let's find it. Okay, final minus initial, so negative 20 minus 0, then time final minus time initial, 3 minus 1, you get negative 20 over 2, which is negative 10 meters per second. Okay, the instantaneous speed. What did we say about the instantaneous speed when you have the instantaneous velocity? It's just the positive value, it's the magnitude. Okay, so what's the magnitude of negative 10? It's just positive 10. What's the instantaneous velocity at t equals 4 seconds? Okay, at t equals 4 seconds, it's obviously it's 0. You don't have to calculate it. It's a horizontal line, فأكيد there's no movement in the position, فأكيد the velocity will be 0. Question 14, how is the motion of the car in region D? Okay, it's moving at a constant speed in the negative direction. أكيد constant because it's a straight line, and negative direction because it's going down. Okay, part B, how would you compare the displacement of each region? Okay, which one has the greatest displacement? I think it's going to be D. أكيد has the greatest displacement. It's the longest line. Then C, I guess. No, then A, then C, then B. D, then A, then C, then B. أكيد, yeah. D has the longest line. It's going from here to here. Then what's the longest one after it? A. Okay, so D greater than A. Then which one comes after it? C. Okay, and then B is 0 because there's no change in the position. Okay, so obviously B at the last. So is it DACB? DACB, yeah. Okay. Then they ask for velocities. Okay. I don't know if you have to calculate. I guess you have to calculate, yeah. Okay, let's calculate it. Let's find the velocity for each one. Akid, the velocity for B would be 0 because it's not moving. So we can just put B then. What has the highest one? Let's calculate for D. We're going from 120 is 4 squares. 20 divided by 4, 5, 120. No. That's 1, 2, 3, 4, 5. 5 squares. So 124 over here. Okay. 124 divided by, okay, the time 5, which is going to be 120 divided by 5 is going to be 20, 26, no, wait, 24.8. Okay, then C will be over here from 124 to 100, that's going to be 24 divided by 5 seconds is going to be 4.8. Right, then A is going to be, I guess you can just take the final minus initial. Okay, 100 divided by 10, because 10 seconds, and 100 from 100 and 0, 10. Okay, so I guess the highest one is going to be D. Okay, this was D, and this was C, and this one was A. So again, I think it's going to be D is the highest, then after that comes A, then after that comes C, and then B. Okay, so again, DACB. DACB. I don't think questions like this will come. The average velocity, oh, so here they ask you to calculate it, of the car in region C to one decimal place. Okay, in region C we found it was 4.8, yeah. How about in region D? Oh, we found it's 24.8, where actually it's negative 24.8 because it's negative 124. We're doing final minus initial, so 0 minus 124. Okay, so it should be negative 24.8. Okay, please pay attention to that. We're talking about velocities, we're not talking about speeds, so you have to always do final minus initial. Question 15. Okay, compare the velocities. Yeah. Okay, B أكيد is 0, so it's gonna be the last one. This is the same question we just did, يعني. D, okay, whatever. Okay. You can actually compare slopes. You can compare slopes. يعني which one is the steepest one? The steepest one, صراحة it looks like D. A and C are equal, right? Yeah, because look, they're covering 2 squares by 2 squares, 2 squares by 2 squares, and then 2 squares by 2 squares. So their slopes are equal. فأكيد A and C are equal. But B is covering 2 squares by 1 square, so it has a larger slope, steeper. Okay, yeah, I see, that makes sense. The total distance that the object travels is 30 meters. Okay, just look at the distance. From 0 to 10, then from 10 to 20, that's 20 meters. Okay, then from 20 back to 10, that's another 10 meters. So 20 plus 10, 30 meters. How far from the object starting point does the object end up after 12 seconds? Okay, so basically they're asking for displacement. How far from the starting point? يعني عم بيقولوا لك what's the displacement. So after 12 seconds, hold on. How far is it? It's 10 meters away from 0, صح? Okay, question. Okay, we're done here. Question 16. The average velocity during the time of 0 seconds, 4 seconds. So we see 0 seconds, it's 0, 0. Okay, 0 seconds, 0 meter. Okay, then at 4 seconds, it's at, it's at uh, 15. No, what's this? 14? Yeah, 4 seconds, 14 meters. Is this, wait, 14, 12, 3? Yeah. So let's do final minus initial, yeah? Because velocity, if you do xf minus xi divided by the time. Final 14 minus 0 over 4 minus 0, 14 over 4, 3.5. Instantaneous velocity at 2 seconds. At 2 seconds, how much is the velocity? Okay, when you want to find instantaneous velocity, and they just give you 1 point, you have to take another point on the straight line drawn for you. Okay, for instantaneous velocity, you always take the straight line. Okay, straight line that is drawn for you. So you would say, okay, what do I do? You have this point at 2 seconds. You're going to tell me, Walid, what's my second point? Do I just do 2 divided by 3? As the 3 divided by 2? Okay, no. You're going to take another point. The easiest point, in my opinion, here would be this one here at 1. At 1 second, it's at 0 meters. Okay, and here at 2 seconds, it's at 3, right? 3. So at 2 seconds, it's at 3 meters. Okay, find the displacement. 3 minus 0, that's over 2 minus 1 equals 3. Okay, so 3 meters per second. That's it for this quiz 2.5, 2.8. Thank you for watching and good luck.